Welcome to solverfy.
So in this problem, we're asked to show that the resultant of the hydrostatic forces acting on a submerged area, or plane area A, is a force perpendicular to the area of the magnitude that we were given before. And now we've defined it, as P bar A, where again, gamma is the specific gravity and P bar is the pressure at the centroid of the area. And then we want to show that P is applied at the center, at the point CP called the center of pressure. So we're basically looking for a center of pressure in this kind of on this surface that's underwater here on some plane, slope plane. So again, I have y prime here as a vertical down, and we have from before just that, P is all of those things. Okay, so here's how the pressure varies with the depth or the distance down this slope. And the force is again given as it was before. And we can integrate that. And we get what we had before. But now if we define P bar as P evaluated at Y bar, so we can just say P evaluated at Y bar is P bar, and we can see that this all stuff becomes P bar, and then we have P bar A. Now, in this case, we have no moments acting, so we can use just the definition of the moment that was acting in the previous problem to find the distance where the center of pressure is. So with respect to where the centroid is. So we have the moment about the x prime axis, or the axis through the x-axis through the centroid, is the force times the distance from the center, the y position of the center of pressure minus y bar. And then we had this from before in the previous problem. So now we can just start, and we know this right here. And so we can plug in and we can see that the specific gravity cancels out, or the specific weight cancels out. The angle cancels out. And what we're left with is y bar A times the center of pressure, the y coordinate of the center of pressure, times the area moment about the x-axis through the centroid, and then plus the area times y bar squared. Well, this is then, back using the parallel axis theorem, is the area moment about the x-axis that is at the water level. So again, we're kind of going backwards here because we had this before, and then we had to subtract this and get this. So this just becomes what was given, that the center of pressure in the y direction is the area moment about the x-axis at the surface of the water divided by the y position of the centroid, or the distance down the slope of the centroid, times the area of that surface. We can do the exact same thing for the other moment. So we have the other moment here. The force that would create that moment is the net force times the difference between the center of pressure in the x direction and the x coordinate of the centroid. Again, plugging things in from before, we can see canceling out. We get that, and doing some rearranging, we see that the x position of the center of pressure times the y, the distance from down the slope to the centroid, times a, equals I, this area moment, and again I should use a double prime here, times the area moment of the the cross area moment about the centroid of between x and y, and then plus a times y bar x bar, right? And if we look ahead in the book, this is now just the cross moment about the xy axis that was defined at the surface of the water, and so then the position of the x position of the center of pressure is ixy all over y bar times a. So we can figure out the area moment properties about the water level at the surface of the and at the surface of the lake or whatever it is, and then figure out where the center of pressure is. And again, it will be down a little bit below the centroid, and again a little shifted away into the plane, and just because the pressure varies linearly as we get deeper